Hello, this is Dr. Hanaa Assil, and today we're doing oxidation reduction reactions. We're going to discuss some questions and answers on this subject for IAS Edexcel chemistry. So this is my first question: in which reaction is calcium oxidized? Again, I'm going to remind you that for it to be oxidized, its oxidation number should increase. So what we need to do is take a look at each of them and determine the oxidation number of calcium. So remember, if we're looking at A, the oxidation number of calcium as an element is 0. It changed into calcium chloride. Remember that calcium is in group 2. When it forms a compound, its oxidation number is +2. So here we're changing from 0 to +2. The oxidation number increased. This is oxidation. So this is actually my answer. But let's take a look at the others. In B, the calcium is a compound, so the oxidation number is +2. It changed to calcium element, which has an oxidation number of 0. Oxidation number decreased, so actually in this case, the calcium was reduced. Now, in C, the calcium oxide has a calcium with oxidation number +2. It changed into a calcium compound also, so that is still +2. So actually, this is not an oxidation reduction reaction. In D also, the calcium has +2 in both cases, so my answer is that first one where the calcium increased in oxidation. Now, this is the next question. It says we have a reaction. It says give the oxidation number of iodine in these two compounds. Now, in ICl, again, let's remind ourselves that if I have two group 7s together, the one that is more electronegative is the one that will be -1. So actually the iodine here, and we said overall a neutral compound is 0. So the iodine here is +1. In ICl3, each chlorine is -1, so I have 3 of them, so that is -3. The overall is 0, so iodine must be +. Are we following how to get that? Remember, the total of a neutral compound has to be 0. So if each chlorine is -1, I have 3 of them, that's -3, so iodine must be +3 for the overall to be 0. In this question, we have iodine trichloride can be made by this reaction, and he's saying by considering oxidation numbers for chlorine, explain whether or not this is a disproportionation reaction. I'm going to remind you, what do we mean by a disproportionation reaction? We said a certain element is oxidized and reduced in the same reaction. So if we look here, he's talking about oxidation numbers of chlorine. So let us see the oxidation numbers of chlorine in each of these. In KClO3, each oxygen is -2. I have 3 of them, so that's -6. That means the K and the Cl must be +6. Now, K alone is in group 1, so that's +1. So chlorine must be +5. In HCl, H is +1, so the Cl has to be -1. In KCl, K is in group 1, it has to be +1, so Cl is -1. In ICl3, we said each Cl is -1. So what is happening to the chlorine? It started with +5 and it changed to -1. That is decrease, that is reduction. But there is no oxidation. The chlorine, if we say we started in HCl -1, it still remained -1. So actually, the chlorine was only reduced. It was not oxidized. So this is not a disproportionation reaction. We said for a disproportionation reaction to occur, the Cl should be at some point oxidized, and in the other point it is reduced, which is not a disproportionation. Please, again, when you have multiple choice, please pay attention. Is he saying which is something or which is not something? So here he's saying which is not a disproportionation reaction. Okay, we said not disproportionation. That means we need only either oxidation or reduction or none of them, so that it's not a disproportionation reaction. Okay, what's happening in A? What is the oxidation number of Cl in ClO minus? Remember, if you have a charge on the group, then that means that the total is that charge. So the ClO minus, the total has to be -1. If each oxygen is -2, then the Cl there is +1. Then when we have Cl minus, its oxidation number is -1. In ClO3 minus, we said each oxygen is -2, so we have -6. In order to have an overall of -1, the chlorine has to be +5. So in this case, chlorine changed once from +1 to -1, decrease, reduction. And another time from +1 to +5, increase, that is oxidation. So this is a disproportionation reaction. Now the other one, what is the oxidation number of iodine? And in I2 it's 0. If we look at the oxygen in O3, this is still an element, so it is 0. The oxygen in water is -2. Hydrogens, each of them are +1, overall 0, so oxygen -2. And we said oxygen is usually -2. Now, what happened to it? Well, the iodine is +5 because each oxygen is -2, so that's -6. The hydrogen alone is +1, so the iodine has to be +5. The oxygen in the element is 0. So what happened to the iodine? It changed from 0 to +5. That is just oxidation. That's an increase in oxidation number, so that's just oxidation. Then the oxygen changed from -2 to 0, so that is oxidation also. So this is not a disproportionation reaction. So this actually should be my answer. Now let us take a look at the others. C says bromine and oxygen and hydrogen. Okay, let's take a look at the bromine. As an element, it's 0. Here the oxygen is, each of them is -2. We want an overall of minus. This is an OH minus. Please note that the balancing has nothing to do with what we're talking about. So I have OH minus, the oxygen is -2, each hydrogen is +1, that is overall a -1. Now the bromine in BRO minus, the overall has to be -1, so that means if oxygen is -2, then the BR has to be +1. Remember that oxygen is more electronegative than bromine. The oxygen has to be -2, so the BR is +1. Here the Br minus has an oxidation number of -1, the overall charge. In water, oxygen is -2, so what is happening? Bromine has changed once from 0 to +1, and that means increase oxidation. And then once from 0 to -1, that's decrease reduction. So this is a disproportionation reaction. Last one here. Iodine is an element, oxidation number 0. Oxygen in water is -2. Now, H is +1, I is -1. In HIO, let's take a look at HIO. The oxygen is -2. The hydrogen has to be +1, so the iodine here is another +1, so that the overall is 0. So that means that the iodine has changed from 0 to -1, decrease in oxidation number, reduction. And once from 0 to +1, increase in oxidation number, oxidation. So this again is a disproportionation reaction. So my answer is B. Here he's saying complete the equation for one of the chemical reactions that occurs when gunpowder burns, whatever. So first of all, this is burning. And when you have burning of all of these things, he has something missing at the end of the reaction. Well, if I burn carbon, what am I supposed to get? Carbon dioxide. And then I balance. You remember how to balance, right? So after the arrow, I have 2 potassiums. So I have, before the arrow, I must put 2 potassiums. Now I have two nitrogens and two nitrogens after the arrow. I have how many oxygens before the arrow? I have 2 times 3, 6. So I need to put a 3 here so that I have 6 oxygens. Now the carbon after the arrow is 3. I need to put a 3 here. So this is balanced. Now he's saying identify two different atoms that have been reduced and state the change in their oxidation number. So, which atoms have been reduced? Well, let us take a look. If we look at nitrogen, what has happened to the nitrogen? What is the oxidation number of nitrogen in KNO3? Each oxygen is -2, so that's -6 for the 3 of them. Each potassium is +1, and that means that the nitrogen has to be +5 to overall to be 0. Okay, it changed to what? It changed to N2. N2 is an element, oxidation number 0. What else has changed? Let's take a look at this sulfur. Oxidation number of sulfur as an element standing alone before the arrow is 0. Now, with K2S, the overall has to be 0. Each potassium is +1, so that's +2, so the sulfur has to be -2. Here, give the oxidation numbers of iodine. Okay, iodine as an element in I2, it's 0. In Ki, the K is +1, so the iodine has to be -1. Here, the oxygen, each of the oxygens is -2. So I have 3 of them, that's -6. So on the other hand, I have one potassium with +1, so the iodine has to be +5 to have a total of 0. Now, what type of reaction is this? The iodine changed once from 0 to -1, reduction, and once from 0 to +5, oxidation. So this is a disproportionation reaction. Another question, which of these is a disproportionation reaction? Now here we're looking for which one is disproportionation. Okay, let's take a look. So you need to take a look at the oxidation number of each of them. So chlorine as an element is 0 in the first one. KBr +1 and -1. Now the Cl, if we say that the Cl2 is 0, in KCl it is -1, this is only reduction, and the Br was oxidized, so this is just a normal redox reaction. So that's not disproportionation. Let's take a look at the second one. The second one, I have chlorine. Chlorine as an element is 0. It changed to what? It changed to -1. The sodium as an element is 0. It changed to what? Sodium is a group 1, so in its compounds it is +1. So also what has happened? The chlorine has been reduced, the sodium has been oxidized. This is a normal redox reaction. Again, number C, we have chlorine as an element, 0. In PCl3, remember this is -1 and -1. Chlorine is -1 if it is with something less electronegative. What about the P4? Well, the P4 as an element is 0. Now it changed into PCl3. If each Cl is -1 and I have 3 of them, that's -3. Overall has to be 0, so the phosphorus here is +3. What about PCl5? Well, each chlorine is -1. I have 5 of them, that's -5. So to have an overall of 0, the phosphorus has to be +5. So here what's happening to the phosphorus? It's changing from 0 to +3, and 0 to +5. In both cases, it was oxidized. The oxidation number increased, so it was oxidized. So this is just an oxidation reaction. Don't regard it as, so the phosphorus was oxidized and the chlorine was reduced, so this is a normal redox. It is not a disproportionation reaction. What about that last one in D? Chlorine as an element is 0. It changed into what? NaCl. We said the Na has to be +1, so the Cl is -1. Now in NaClO, the oxygen is -2. The sodium alone is +1, so the chlorine has to be +1 so that they have an overall of 0. So the chlorine changed once from 0 to -1, reduction, and one's from 0 to +1 oxidation, this is a disproportionation reaction. Are we following? It's easy once you know how to calculate the oxidation number of. Okay, what about this question? The chlorine gas is generated in the apparatus by this reaction. Okay, he says show by the use of all relevant oxidation numbers that this is a redox. Now, a redox means something should be oxidized and something should be reduced. So what is happening here? If we look at the Cl, in Cl minus, it is -1. It changed into what? Cl2, that's 0. It's an element. Now, the manganese, let's look at the manganese. Of course, the H, if you look at the H in both cases, in all cases, it's +1. If you look at the oxygen, in all cases, it's -2. But what about the manganese? Now, in MnO4-, we have each oxygen is -2, so I have -8 for the 4 oxygens. But I want the overall to be -1. So the manganese is +7. Now, when I have Mn2+, the manganese oxidation number is +2. So what happened is the chlorine changed from -1 to 0. That is oxidation. So the chlorine was oxidized. The manganese changed from +7 to +2. That is a decrease in the oxidation number. So that is the reduction. Okay. Again, we said, what is the oxidation number of oxygen in OF2? Remember that we said oxygen is usually -2, unless if in certain exceptions. One of the exceptions is in OF2, and we said the F is more electronegative than the oxygen. So the F has to be minus. Now each F is -1, so that is 2 fluorines, that's -2. So the oxygen has to be +2 for an overall of 0. This question says, give the oxidation numbers of iodine in these compounds. So in iodine monochloride, we said, what is iodine monochloride? It's ICl. And we said if the Cl is -1, then the iodine has to be +1. Iodide ion, well, if you write it iodide, it has -1. That is the oxidation number. So the oxidation number in the ion is the charge on it. Now, iodine as an element, we said as an element, the oxidation number has to be 0. Then he's saying, write the ionic equation for this reaction. What is he reacting? So he says iodine monochloride, that is ICl, reacts with the iodide ion. Now that changes it into what? Into iodine and chloride ion. Okay, so this is the ionic equation, and it is balanced and everything is correct. Okay, when iodide ion reacts with concentrated sulfuric acid, another product X can be detected. X is a toxic gas with a smell of rotten eggs. If you have not done this before, then the toxic gas with the smell of rotten eggs is H2S. Okay, so he's saying oxidation number of sulfur in sulfuric acid. Well, sulfuric acid is H2SO4. So each oxygen is -2, so that's -8. Each hydrogen is +1, so that's a total of +2. So the sulfur has to be +6 for an overall of 0. What is the oxidation number of S in H2S? H2S, each hydrogen is +1, so that is a total of +2 for the two of them. So the sulfur has to be -2. This question again says, which is a disproportionation reaction? Well, let's see. That first question, the calcium in calcium carbonate, calcium is in group 2, so it's +2. It changed also into a compound, so that is +2. So +2 to +2, no oxidation reduction in this reaction. What about question B, or this choice B? In choice B, you have H2O2, hydrogens are +1, the oxygen is -1 in hydrogen peroxide because the overall has to be 0. Now it changes into what? Into H2O. H2O, the oxygen is -2. and O2, the element, is 0. So the oxygen is changing from -1 to -2, that's a reduction. And once from -1 to 0, that is oxidation. So this is a disproportionation reaction. If we go through the others, we will find that they will not be oxidation reduction. Oxygen difluoride is produced in the reaction between fluorine. Give the oxidation numbers of fluorine and oxygen. So fluorine in F2 is an element, it's 0. The oxygen in OH minus, remember, oxygen is usually -2, and if you regard the hydrogen as +1 and overall -1, then the oxygen is -2. In OF2, we said this is where the oxygen is +2 because each fluorine has to be -1. In F minus, the fluorine has a -1. In oxygen in water, it's -2. So these are the oxidation numbers. Now he's saying use them to explain why this is a redox. Where do we have oxidation and where do we have reduction? Well, you should realize that the fluorine, if we're looking at the fluorine, it changed from 0 to -1. That is reduction, decrease in oxidation number. Now, the oxygen changed from -2 to +2 in the OF2. So that is an oxidation due to the increase in oxidation number. This is a question where he says write the overall equation for the reaction. So he's trying to get you to do the addition of these two half equations. And we said, if I have these two half equations, what should I do? We said the first thing, it's already balanced. So the first thing is we try to make the number of electrons equal. So one of them has 2 electrons, the other one has 8. I can multiply the upper one by 4 so that the number of electrons will be the same. Now I can add up these two equations, cancel the electrons, and we said whatever is before the arrow is added up and whatever is after the arrow is written. So that will be your overall equation. Please sit down and try doing these questions before looking at the answers. In which of these reactions is a sulfuric 4? Sulfuric 4, this is H2SO3, or what we call sulfurous acid. In which reaction is it acting as an oxidizing agent? Now, for it to act as an oxidizing agent, that means the other reactant should be oxidized. For H2SO3 to be oxidizing, that means it is reduced, and that means the other reactant is oxidized. Now, where is the other reactant oxidized? Well, let's take a look at that first equation. The oxygen in all cases is -2. This is not an oxidation reduction reaction. In choice B, also, there is no oxidation reduction. All of them are -2 for oxygens. In H2SO3, in the third equation, what do we have? The H2SO3 plus the FeCl3. In the FeCl3, the chlorine is -1. In FeCl2, the chlorine is -1. In HCl, the chlorine is -1. So all of this is no oxidation reduction. Let's look at this last one. In the last one, what is happening? The sulfur is changing from -2 in H2S to 0 as an element. This is increase in oxidation number. So that means the sulfur was oxidized, and that means the H2SO3 is acting as an oxidizing agent. This next question says, by referring to the relevant oxidation numbers, explain why this is disproportionation. Again, disproportionation means you must have the same element oxidized and reduced. So let's look at the oxidation number of chlorine. As an element, it's 0. In HOCl, each hydrogen is +1. The oxygen is -2, so here the chlorine has to be +1. In HCl, it is -1. So the chlorine was oxidized from 0 to +1 and reduced from 0 to -1. And that means this is a disproportionation reaction. This next question says, find out the oxidation number of sulfur in this compound. First of all, if we have water of crystallization, the water of crystallization is a sort of a separate entity. So it is not added with the rest of the compound. So actually what we're looking at is the KAlSO4 twice. So if we're looking at this, what is the oxidation number of sulfur here? Well, let's take a look. The potassium has to be +1. It's in group 1. Aluminium is in group 3, so it has to be +3. And that means that the two SO4s should balance the K and the Al. The K and the Al are +4, so the two sulfates have to be -4, so each sulfate is -2. And that is actually how we write sulfate. It should have -2. So the sulfates as a whole, SO4 is -2. Each oxygen is -2, that's -8. So the sulfur has to be +6 in order to have an overall of -2, and that means +6 is our answer. Okay, in this question, he's saying what is the oxidation number of chlorine in HClO3? Well, let's take a look. The hydrogen has to be +1. The oxygen is -2, so I have a total of -6. Now, that means that the chlorine has to be +5 in order to have an overall of 0. This next question says, what is the oxidation number of nitrogen in ammonia and nitrogen monoxide? Well, in ammonia, each hydrogen is +1, so the nitrogen has to be -3. Now, NO, each oxygen is -2, so the nitrogen has to be +2. What is the oxidation number of phosphorus in P4O7? Again, in P4O7, the phosphorus, I have 4 of them. If each oxygen is -2, that means I have -12. Then that means the phosphorus has to be +3 in order to have an overall of 0. Are we following how to calculate all of this? It should be easy by now. Chlorine, Cl2 is 0. NaCl, the Na is +1, so the Cl is -1. NaClO, we said the Na is +1, and each oxygen is -2, so the Cl has to be +1. So if he says what type of reaction this is, the chlorine changed from 0 to -1 and 0 to +1, so this is a disproportionation reaction. This question says, use the changes in oxidation number to show that this is redox. Again, when I have the barium changed from 0 to +2. Barium is in group 2. Chlorine changed from 0 to -1. So barium was oxidized and chlorine was reduced. In this question, he's saying, is the production of iodine pentoxide in this reaction a redox? Okay, let's take a look. If I look at the HiO3, the iodine, what is the oxidation number of iodine? Well, oxygens are -2. I have 3 of them, that's -6. The hydrogen is +1, so the iodine has to be +5. Now it changes into I2O5. Well, each oxygen is -2, so I have -10. So the iodine is still +5. So this is not a redox reaction because the oxidation number of iodine in both cases is just +5. It did not change. He says an alkaline solution is produced when barium reacts with cold water. State the initial and final oxidation number of any element that changes its oxidation number. So if I have this reaction, barium plus water to give barium hydroxide, what has happened to the barium? The barium changed from 0 to +2. The oxygens did not change, but the hydrogen changed from +1 to 0. So this is an redox reaction. The barium increased in oxidation number from 0 to +2. The hydrogen decreased from +1 to 0. Again, what is the oxidation number of chlorine in this compound? Well, each oxygen is -2. So -2 times 7, that's -14. So each chlorine has to be +7 in order to have an overall of 0. this reaction, he says the ion in this reaction undergoes what? Well, what's happening to the ion? It is changing in Fe2O3. Remember that this is iron 3, so this is plus 3 changing to iron as an element, so that is 0. This is a reduction reaction. The iron in this case has been reduced. Okay, that's the end of the questions here. I hope this chapter is now much easier. Thank you for listening.